Part 3. Directions. In this part, you will hear 3 talks or lectures. The talks or lectures will not be repeated. There are 5 questions for each talk or lecture. For each question, choose the right answer, A, B, C, or D. Then, on the answer sheet, find the number of the question and fill in the space that corresponds to the letter of the answer you have chosen. Questions 21 to 25.
Listen to part of a lecture in a geology class.
First, you have some time to look at questions 21 to 25.
Okay, today we're going to discuss the 4 major types of drainage patterns. I trust you've already read the chapter, so you'll recall that a drainage pattern is the arrangement of channels that carry water in an area. And these patterns can be very distinctive since they're determined by the climate, the topography, and the composition of the rock that underlies the formations. So consequently, we can see that a drainage pattern is really a good visual summary of the characteristics of a particular region, both geologically and climatically. In other words, when we look at drainage patterns, we can draw conclusions about the structural formation and relief of the land as well as the climate. Now, all drainage systems are composed of an interconnected network of streams, and when we view them together, they form distinctive patterns. Although there are at least 7 identifiable kinds of drainage patterns, for our purposes we're going to limit our study to the 4 major types. Probably the most familiar pattern is the dendritic drainage pattern. This is a stream that looks like the branches of a tree. Here's an example of a dendritic pattern. As you can see, it's similar to many systems in nature. In addition to the structure of a tree, it also resembles the human circulation system. This is a very efficient drainage system because the overall length of any one branch is fairly short, and there are many branches, so that allows the water to flow quickly and efficiently from the source or sources. Okay, let's look at the next example. This drainage pattern is referred to as a radial pattern. Notice how the streams flow from a central point. This is usually a high mountain or a volcano. It kind of looks like the spokes that radiate out from the hub of a wheel. When we see a radial pattern, we know that the areas experienced uplift and that the direction of the drainage is down the slopes of a relatively isolated central point. Going back to the dendritic for a moment, the pattern's determined by the direction of the slope of the land, but the streams flow in more or less the same direction, and so it's unlike the radial that had multiple directions of flow from the highest point. Now, this pattern is very different from either the dendritic or the radial. This is called a rectangular pattern, and I think you can see why. Just look at all of those right-angle turns. The rectangle pattern is typical of a landscape that's been formed by fractured joints and faults, and because this broken rock is eroded more easily than unbroken rock, stream beds are carved along the jointed bedrock. Finally, we have the trellis pattern. And here in this example, you can see quite clearly how the tributaries of an almost parallel structure drain into valleys and form the appearance of a garden trellis. This pattern forms in areas where there are alternating bands of variable resistance. And by that, I mean that the bands of rock that are very strong and resistant to erosion alternate with bands of rock that are weak and easily eroded. This often happens when a horizontal plane folds and outcroppings appear. So, as I said, as a whole, these patterns are dictated by the structure and relief of the land. The kinds of rocks on which the streams are developed, the structural pattern of the folds, faults, and uplift will usually determine a drainage system. However, I should also mention that drainage patterns can occasionally appear to be, well, out of sync with the landscape. And this can happen when a stream flows over older structures that have been uncovered by erosion, or when a stream keeps its original drainage system when rocks are uplifted. So when that happens, the pattern appears to be contrary to the expected course of the stream. But I'm interested in your understanding the basic drainage system, so I don't plan to trick you with test questions about exceptional patterns. But I expect you to know that exceptions to the patterns can occur when geological events influence them.
What is this lecture mainly about? Listen again to part of the lecture and then answer the following question.
Okay, today we're going to discuss the four major types of drainage patterns. I trust you've already read the chapter, so you'll recall that a drainage pattern is the arrangement of channels that carry water in an area.
Why does the professor say this?
I trust you've already read the chapter, so you'll recall that a drainage pattern is the arrangement of channels that carry water in an area.
How does the professor introduce the dendritic drainage system? Why does the professor mention the spokes of a wheel? What does the professor imply when he says this?
So I don't plan to trick you with test questions about exceptional patterns.
Questions 26 to 30.
Listen to part of a discussion in an astronomy class. The professor is talking about the solar system.
First, you have some time to look at questions 26 to 30.
Okay, let's get started. As you know, today I promised to take you on a walk through the solar system. So let's start here with the central object of our solar system, the Sun. As you can see, the Sun is about 5 inches in diameter, and that's about the size of a large grapefruit, which is exactly what I've used to represent it here in our model. So I'm going to take 2 steps, and that will bring me to the planet closest to the Sun. That would be Mercury. 2 more steps to Venus, and 1 step from Venus to Earth. Let's continue walking 3 steps from Earth to Mars. And that's as far as I can go here in the classroom, but we can visualize the rest of the journey. Don't bother writing this down, just stay with me on this. So, to go from Mars to Jupiter, we'd have to walk a little over half the length of a football field. So that would put us about at the library here on campus. And then, to get from Jupiter to Saturn, we'd have to walk another 75 yards. So by then, we'd be at Harmon Hall. From Saturn to Uranus, we'd have to walk again as far as we'd gone in our journey from the Sun to Saturn. And so we'd probably be at the Student Union. From Uranus to Neptune, we'd have to walk the same distance again, which would take us all the way to the graduate dormitory towers. From Neptune to Pluto, another 125 yards. So we'd end up about 1/3 of a mile from this classroom at the entrance to the campus. Okay, that's interesting. But now I want you to think about the orbits of the planets in those locations. Clearly, the first 4 planets could orbit fairly comfortably in this room. But to include the others, we'd have to occupy an area of more than 6/10 of a mile, which is all the way from College Avenue to Campus Drive. Remember that for this scale, the sun is 5 inches, and most of the planets are smaller than the lead on a sharpened pencil. Okay, with that in mind, I want you to think about space. Sure, there are some moons around a few planets and a scattering of asteroids and comets, but really, there isn't a lot out there in such a vast area. It's pretty empty. And that's what I really want to demonstrate with this exercise. Now, it would really be even more impressive if you could actually make that walk. And actually, you can, if you visit Washington, D.C., where a scale model is set up on the National Mall, starting at the National Air and Space Museum and ending up at the Arts and Industries Museum. I did that a couple of years ago, and it was, amazing. Even though I knew the distances intellectually, there is nothing like the experience. Has anybody else done that walk?
I have, and you're right, it's an eye-opener. It took me about 20 minutes to go from the sun to Pluto because I stopped to read the information at each planet. But when I made the return trip, it was about 10 minutes.
Did you take pictures?
I didn't. But, I don't think it would have captured it anyway.
I think you're right. What impressed me about doing it was to see what was not there. I mean, how much space was between the bodies in the solar system. And a photograph wouldn't have shown that. So, back to our model. Here's another thought for you. The scale for our model is 1 to 10 billion. Now, let's suppose that we want to go to the nearest star system, the neighbor to our solar system. That would be the Alpha Centauri system, which is a little less than 4.5 light years away. Okay, let's walk it on our model. Here we are on the east coast of the United States. So if we want to make it all the way to Alpha Centauri, we have to hike all the way to the west coast, roughly a distance of 2,700 miles. And that's just the closest one. To make a model of the Milky Way galaxy would require a completely different scale because the surface of the Earth wouldn't be large enough to accommodate a model at the scale of 1 to 10 billion. Now, let's stop here for a minute because I just want to be sure that we're all together on the terms solar system and galaxy. Remember that our solar system is a single star, the sun, with various bodies orbiting around it. 9 planets and their moons, and asteroids, comets, meteors. But the galaxy has a lot of star systems, probably 100 billion of them, okay? This is important because you can be off by almost 100 billion if you get confused by these terms. Not a good idea. Okay, then. Even if we could figure out a different scale that would let us make a model of the Milky Way galaxy, even then, it would be challenging to make 100 billion stars, which is what you'd have to do to complete the model. How many would that be exactly? Well, just try to count all the grains of sand on all the beaches on Earth. That would be about 100 billion. But of course, you couldn't even count them in your lifetime, could you? If you'd started counting in 1000 BCE, you'd be finishing just about now, with the counting, I mean. But of course, that assumes that you wouldn't sleep or take any breaks. So what am I hoping for from this lecture? What do you think I want you to remember?
Well, for one thing, the enormous distances.
And the vast emptiness in space.
That's good. I hope that you'll also begin to appreciate the fact that the Earth isn't the center of the universe. Our planet, although it's very beautiful and unique, is still just one planet orbiting around just one star in just one galaxy.
What is the discussion mainly about? Listen again to part of the lecture and then answer the following question.
And that's as far as I can go here in the classroom. But we can visualize the rest of the journey. Don't bother writing this down. Just stay with me on this.
Why does the professor say this?
Don't bother writing this down. Just stay with me on this.
Why wouldn't a photograph capture a true picture of the solar system walk? How does the professor explain the term solar system? Listen again to part of the lecture and then answer the following question.
So what am I hoping for from this lecture? What do you think I want you to remember?
Well, for one thing, the enormous distances.
And the vast emptiness in space.
That's good. I hope that you'll also begin to appreciate the fact that the Earth isn't the center of the universe.
Why does the professor say this?
So what am I hoping for from this lecture? What do you think I want you to remember?
Questions 31 to 35.
Listen to part of a discussion in a psychology class. The professor is discussing defense mechanisms.
First, you have some time to look at questions 31 to 35.
Okay, we know from our earlier study of Freud that defense mechanisms protect us from bringing painful thoughts or feelings to the surface of our consciousness. We do this because our mind simply can't tolerate these thoughts. So defense mechanisms help us to express these painful thoughts or feelings in another way, while we repress the real problem. The function of defense mechanisms is to keep from being overwhelmed. Of course, the avoidance of problems can result in additional emotional issues. And there's a huge distinction between repression and suppression. Anybody want to explain the difference?
I'll try it. I think repression is an unconscious response to serious events or images, but suppression is more conscious and deals with something unpleasant, but not usually, well, terrible experiences.
I couldn't have said it better. Now remember that the thoughts or feelings that we're trying to repress may include, just to mention a few, anger, depression, competition, fear, envy, hate, and so on. For instance, let's suppose that you're very angry with your professor. Not me, of course. I'm referring to another professor. So, you're very angry because he's treated you unfairly in some way that could cause you to lose your scholarship. Maybe he failed you on an examination that didn't really cover the material that he'd gone over in class, and an F grade in the course is going to be unacceptable to your sponsors. So this would be very painful, as I'm sure you'd agree. And I'd say it would qualify as a serious event. So let's take a look at several different types of defense mechanisms that you might employ to repress the feelings of disappointment, rage perhaps, and even violence that you'd feel toward the professor. Most of them are named, so the mechanism's fairly obvious, and one of the most common mechanisms is denial, which is...
If I want to deny something, I'll just say I'm not angry with the professor.
Exactly. You may even extend the denial to include the sponsors, and you could tell your friends that they'd never revoke your scholarship. And this mechanism would allow you to deny the problem, even in the face of direct evidence to the contrary. Let's say a letter from the sponsor indicating that you won't receive a scholarship for the next term. Okay on that one? Okay. How about rationalization?
Well, in rationalization, you come up with some reasons why the professor might have given an unfair test.
And how would you do that?
Well, you might defend him. You could say that he gave the test to encourage students to learn information on their own. Is that what you mean?
Sure, because you'd be rationalizing, providing a reason that justifies an otherwise mentally intolerable situation. Okay, another example of rationalizing is to excuse the sponsor for refusing to hear your side of the situation. You might say that sponsors are too busy to investigate why students are having problems in their classes. And you might do that while you deny your true feelings that sponsors really should be more open to hearing you out.
So when you deny something, when you use denial, you're refusing to acknowledge a situation, but when you use rationalization, you're excusing the behavior?
Excellent summary. So, now let me give you another option. If you use a reaction formation as a defense mechanism, you'll proclaim the opposite of your feelings. In this case, what would you say about the professor?
I'd say that I like the professor when in fact I hate him for depriving me of my opportunity.
And you might insist that you have no hard feelings and even go so far as to tell your friends that he's an excellent teacher. You see, a reaction formation turns the expression of your feelings into the opposite reaction, that is, on the surface. And that brings us to projection, which is a defense mechanism that tricks your mind into believing that someone else is guilty of the negative thought or feeling that you have.
Can you give us an example of that one?
Okay. Feelings of hate for the professor might be expressed by telling classmates about another student who hates the professor, or even suggesting that the professor has strong feelings of hate for you, but you really like the professor yourself. So you would attribute your feelings to someone else. Get it?
So if I hate someone, I'd believe that another person hates him or that he hates me.
But you wouldn't admit that you hate him yourself.
Okay, that's projection.
Now, displacement serves as a defense mechanism when a less threatening person or object is substituted for the person or object that's really the cause of your anxiety. So instead of confronting the professor about the unfair test, well, you might direct your anger toward the friend who studied for the test with you, and you could blame him for wasting your time on the material that was in the book and notes. Of course, there are several other defense mechanisms like fantasy, which includes daydreaming or watching television, maybe to escape the problems at school, or regression, which includes immature behaviors that are no longer appropriate, like maybe expressing temper in the same way that a preschooler might respond to having a toy snatched away. And your textbook contains a few more that we haven't touched on in class. Just one more thing. It's good to understand that the notion of unconscious thoughts and the mechanisms that allow us to manage them, that this is a concept that goes in and out of fashion. Many psychologists rejected defense mechanisms altogether during the 70s and 80s. And then in the 90s, cognitive psychologists showed a renewed interest in research in this area. But I must warn you that although they found similar responses, they tended to give them different names. For instance, denial might appear in a more recent study as positive illusion, or scapegoating might be referred to instead of displacement. But when you get right down to it, the same categories of behavior for defense mechanisms still exist in the research, even if they're labeled differently. And in my view, if you compare Freud's traditional defense mechanisms with those that are being presented by more modern researchers, you'll find that Freud's easier to understand and gives us a broader perspective. And if you understand Freud's categories, well, you'll certainly be able to get a handle on the newer terms. What is exciting about the modern studies is the focus on coping skills and what's being referred to as healthy defenses. So next time, we'll take a look at some of these processes.
What is the discussion mainly about? How does the student explain the term repression? Listen again to part of the discussion and then answer the following question.
For instance, let's suppose that you're very angry with your professor. Not me, of course. I'm referring to another professor. So, you're very angry because he's treated you unfairly in some way that could cause you to lose your scholarship.
Why does the professor say this?
Not me, of course. I'm referring to another professor.
Which of the following is an example of displacement that was used in the lecture? According to the professor, what happened in the 1990s?
That is the end of Part 3. Now, you will have 7 minutes to transfer your answers to an answer sheet.